Have you ever wondered how the universe's building blocks are organized, or what makes gold different from silver or helium different from hydrogen? Welcome to the fascinating world of the periodic table, a chemist's roadmap to understanding the elements that make up the universe. The periodic table is divided into several groups, each with its own unique characteristics. First up, we have the alkali metals. These are found in Group 1. They're known for their reactivity with water, which often results in dramatic explosions. Sodium and potassium are among the most recognized in this group. Next, in Group 2, we have the alkaline earth metals. They too are reactive, but less so than their cousins in Group 1. They include elements like magnesium and calcium. Transition metals take up the center stage in Groups 3 to 12. These are your everyday metals like iron, copper, and gold. They're malleable, ductile, and conduct electricity and heat. Then we have the post-transition metals. They're a mixed bag, found in Groups 13 to 16. They include elements like aluminum and lead. Despite being metals, they're quite poor conductors of electricity. Group 17 houses the halogens. These non-metals are very reactive, especially with alkali metals. Some familiar ones include chlorine and iodine. On the far right of the table, in Group 18, we find the noble gases. They're the wallflowers of the periodic table, very stable and non-reactive. They include gases like helium and neon. Lastly, we have the lanthanides and actinides, also known as the rare earth metals and radioactive metals. They're found in the two rows usually depicted below the main body of the table. They include elements like uranium and plutonium. Now let's bring it all together. The periodic table is a masterful organization of elements, grouped based on their chemical properties. We've talked about alkali metals and their explosive reactivity, alkaline earth metals with their slightly subdued reactivity, transition metals that are the workhorses of the metal world, post-transition metals that are a bit of an oddball, reactive halogens, the stable noble gases, and the often overlooked lanthanides and actinides. Whether it's gold in your jewelry, helium in your party balloons, or uranium powering nuclear reactors, each element plays a unique role in our world, and their stories are told through the periodic table. So the next time you look at a gold ring or fill a balloon with helium, remember, you're interacting with a tiny piece of the universe's vast chemical diversity. The periodic table is not just a chemist's tool, it's a testament to the wonder of science and the complexity of the universe.